The practical machine learning for computer vision. So we shall be looking at what is a tensor. A tensor in mathematics is called a vector or a matrix depending on the number of dimensions. So if it is a 1D array, then it's called a vector. If it's a 2D array, it's called a matrix. And what do we mean by the 1D? The 1D means the one-dimensional array, meaning that you just need one index to be able to access any element in the vector. Of course, for 2D array, it means that you need two indices to be able to access any element in a matrix. So, and a tensor is an array that could have any number of dimensions. So if it is a vector, then the dimension is 1. If it is a matrix, the dimension is 2, and the dimension could be 3, 4, and infinite. In computer vision, images are represented as a tensor because it's a multi-dimensional array or multi-dimensional list. So the number of dimensions is called the rank. So if you have a matrix that has 12 rows and 18 columns, then the rank is 2 because you need just two indices to be able to access any element there. And the shape is 12, 18. So a common array math library that is used in Python to process tensor is Numpy. But Numpy suffers from has a problem with that is that they are not hardware accelerated. And what does that mean? It runs only on CPU, central processing unit. But if you want a more efficient processing on tensors, then you want to run it on a GPU, that is graphics processing unit, which is a kind of hardware that is optimized for vectorized or matrix operations. Okay, so in Numpy, for you to be able to create a Numpy vector or 1D array, you just need to supply a list and use the method array, and you pass in the list, and this gives you a 1D array. And there's also some default function like zeros. If you want all the elements to be zeros, then you can use the zeros method inside Numpy, but you need to supply the shape of your tensor. So for instance, the shape here is 12 by 18. That means it's going to have 12 rows and 18 columns. Now, when it is more than 2 or 3 3D, when the rank is more than 2, it becomes difficult to visualize for human. But that tensor still exists, and computer can well represent that. So those are the limitations of humans and where computer is better. So for instance, here you're having 43783. It's difficult for human to represent this, but computer can represent a tensor that has this shape because each of these represents a unique dimension in that tensor. So I want to quickly demonstrate this one, and let's see what that looks like. So if I import numpy as np and run that, and I have this, and if I print this x5d, we can see what this gives us. So this is even truncated here, so these are truncated, so it's difficult to visualize the way this is actually is. It's a lot, and we can't even visualize it. But if I want to run the same thing and I just say, okay, give me one that has just 4. Let's say it's just have 4, say x nd, so x nd. So it's going to give me a matrix that has all zeros, but the shape is going to be 4. And what does that mean? That means it's a vector, because that's just 1D. So just going to give me a vector. You can see this is just a vector. You can see just have only one square bracket. As soon as I supply the second component, because it's a first component, as soon as I supply the second component, then it becomes a matrix. Then I'm going to be having 2 square bracket. So you could see this is the first square bracket, this is the closing, and this is the second bracket inside. So, and inside the outer bracket, which is this, and I have 4 rows, 1 2 3 4, and I have 2 columns. And if I just want to have 4 rows and 1 column, you know what that's going to be. So if I just put this as 1, so I'm going to get rid of this column. So let's try that. So you see that, so I have 4 rows and I have just 1 column. Okay, so all the element is zeros. But if I now had the third dimension, you will see that the outer bracket is going to turn to 2. So the number of brackets will now be 3 by the time I do that. So you can see the internet is running slow. So you can see now we now have 2 outer bracket. You see we have 2 outer bracket. So it's even becoming more difficult to visualize now. And so you still have 4 rows, and I can even visualize where is the 1 column. So that's what but this does exist in space. So once it's more than 2, it's difficult to just visualize that. If you just have 4 by 4, that is 4 rows, 4 columns, you can easily visualize that 4 rows, 4 columns, and that is a multi-dimensional array list. Okay, so that's that. Now to obtain a TensorFlow, so to enjoy the benefit of the hardware acceleration, you can use TensorFlow or PyTorch. So if you import TensorFlow, you can convert your NumPy to a TensorFlow using the function convert to tensor, and you supply your NumPy, and you can specify the default data type you want to give it, but that's not a must. And you can take back your TensorFlow back into a NumPy. So we'll quickly demonstrate this. So let's see how this works. So you can see in here, so if I come in here and I import TensorFlow as TF, and I run that, and I drop this. So by the time I run this, I don't have an X, so we have what we call XND. So I'm going to put ND here. So this is going to give me a TensorFlow. So this is a TensorFlow TF, then tensor, the shape is 4 by 4, and it's coming from a NumPy. So it's created from this NumPy. So that's right. So you can always check the type of a data of a variable in Python using the type keyword, and that tells you this is a TensorFlow data type. And I'll leave you to convert it back to NumPy using just the NumPy. So in summary, TensorFlow runs on GPU if it is available. If not, it will default to running on CPU. It's much faster to run your matrix operation or vectorized operation in TensorFlow than on a GPU than running it on the CPU. Now here it says that when you have operations to do, it's good that you try to put it in a vector rather than doing it in scalar operation. And what does that mean? I'm quickly going to demonstrate what that means. Let's say that you have 3 vectors. So this is my first vector and I have 1, 2, 3. So this is my first vector. And I have another vector, the second vector, let's say I have 4, 6, 8. Okay. And I have the third vector, let's say I have 10, 12, 20. So each of these are what you refer to as column vector. And I want to multiply this one by 3. I want to multiply each of them by 3. I want to multiply each of them by 3. So what we learned before is saying that instead of doing it 3 times like this, I can just put all these vector into a matrix, put them in a matrix, combine them together into a matrix like this, 10, put all of them together so I know each column represents my individual vectors, and just multiply the whole matrix by this. So that's what this is saying, that you can, the more you can do with TensorFlow, the more efficient your process. So it's also more if you vectorize your code, that is to process batches of your images so that you are not carrying out a single in place tensor operation. So that's what this is saying. So this is much more efficient. This will run much more efficient finishing this and coming here and coming here. You just get your answer back immediately. Alright, that's it for now. So next time we'll continue. Thank you very much, and we'll see you in the next one. Bye for now.